automatic audio semantic concept discovery for video retrieval. So first, what is audio semantic concept? So the semantic concept we mentioned is simply some sound event like laugh or scream or music. So why do we use it for video retrieval? So the reason is that we cannot use the audio signal or video signal directly for any semantic search. So we need to fill the gap between the low-level features and high-level semantics. So that's why we'll define some mid-level semantic concept to bridge the gap. And what is the problem of the current semantic concept we used? First, so most of the semantic concepts are defined in some specific domain. So like if you use some sports video, you might define such concepts. However, if you want to apply in other domain, this knowledge cannot be transferred. And also another problem is that usually this vocabulary of concepts is defined by linguistics, so they don't know whether they are effective to distinguish the content that we hope to distinguish. So in order to solve this problem, I propose a novel framework to do semi-automatic audio concept discovery. Basically, our method can be divided into 3 steps. First, we'll transform the audio stream into a sequence of words. So we simply run k-means to get codebook of the MFCC feature, and we assign each feature into cluster. So this step helps us to handle the variance of the data distribution. And after that, in order to generate some abstract descriptor to cover the real data distribution, we need to find some abstract descriptor. And inspired by some method in document clustering, we learn the topic model, use LDA over all the clips of videos. And finally, the most challenging task is how to map to the semantic concepts. Although the descriptor we learned from topic model can cover the data distribution, however, it doesn't can map to the semantics we expected directly. So in this way, we have an initial annotation of our data, and we estimate the topic distribution using the LDA we trained in previous step on some annotated segment. And then we apply hierarchical clustering using the topic distribution. And then we can build a hierarchical structure of this candidate's concept. And we can try to discover some new concept within this structure. And I will talk about the experiments and results. So this is the data set we use. It's multimedia event detection data set. And we have an annotation of 42 audio semantic concepts. So some linguistic definition can be referred to interspeech paper. And so since it's an unsupervised method, it's hard to evaluate whether your new discovered semantic concept is reasonable. So I will show you 2 experiments to show you that this method can provide some reasonable results. So first, we examine the method on or existing annotation of the semantic concepts. We estimate the topic distribution for each concept class, and then we apply the hierarchical clustering. And then through the hierarchical structure, we can find that the speech, noun, and singing, they belong to similar, they can be grouped into one cluster, and also there are other candidate cluster. We can say some of them are reasonable, but some maybe you cannot understand it. But one thing that can be explained is that, like crowd, why it will be grouped into music class, because most of the sound in multimedia data, they have overlapping. So maybe when there's sound of crowd of people, there's also the background of music. So another thing is discover a new concept. And I will give you an example of the singing case. So I do the hierarchical cluster method on or singing annotated data. Okay. So I will run the example. So some new discovered concept. Like this one is some male canto, some very professional song, and so this one is usually seen happen in birthday party, and also so this one is just humming. So the second one just from the previous class. So we can say that actually now our method cannot distinguish these two classes, but they can distinguish 1, 2, and 3. And so the final question is that how many concepts should be used, and we propose a metric in distinguished event-based video classifier. And
Okay.
in the
Thank you. Thank you.